Okay, so basically in this lab we will see how to predict the bike trip duration with the regression model in Bqml. 1 minute. Okay, I agree to the terms and condition. Yes, fine. So first we need to know what is Bqml. Okay, let's Google it. Open it. Click on learn more. So what is the Bqml is basically the Bigquery Ml. So ML is the machine learning model, right? So in the machine learning model, what we will do is we will train the models, evaluate it, predict the model, and deploy the models. All these are come under the machine learning. So, but BigQuery is what we know is to execute some SQL queries to fetch the data, right? To update the data, to fetch the data. But what is BigQuery and ML? How the BigQuery is working on the ML? So basically, this is you can say a latest technology. By using some simple standard SQL queries, we can create a machine learning models. So as we are using the simple SQL queries and we are using the BigQuery tool, and we are creating the machine learning models, so that we called it as a BigQuery ML. So here is the definition. BigQuery ML lets you to create and execute machine learning models in BigQuery using SQL. Okay, so BigQuery ML functionality is available using, so you can run the BigQuery, or you can create the machine learning model using the console, simple using the web UI interface by just clicking some few buttons, using the command line tool, that is the BQ tool, using the REST API, and using the external notebook. If you see my yesterday videos, we use the Jupyter notebook, and in that we use the BigQuery by using the magic method of the BigQuery. So yeah, this is the some basic intro what is BigQuery ML. So BigQuery ML is basically to prepare the machine learning models in the BigQuery. BigQuery is one of the service provided by the Google, and using the simple SQL commands. So we will just write a simple SQL command and we will prepare the models. So what all the models supported by the BigQuery ML? So many models supported by the BigQuery ML, like linear regression, logistic regression, k-means, matrix factorization for the recommendation system, time series, XGBoost, DNN, that is a deep neural network, AutoML. So many models supported by the BigQuery ML. Okay, so this is the basic intro. Let's go to the lab. So in this we need to predict a trip duration. So duration is basically a number. So whether it is for whether if any person took a bike on the rent, so for how much duration that particular person will took a bike on the rent. So we need to find the trip duration. So the duration should be a number, like whether the person take a bike for 1 hour, 2 hour, 3 hour, 4 hour. So it's a number. So that's why we will use the regression model. Okay, so these are just a basically overview. So BigQuery, we know it's a no-ops tool for the database, where we can use the terabytes and terabytes of data without any infrastructure, which uses simple SQL commands, and it is the pay-as-you-go model. So basically in pay-as-you-go model, whatever you will use, only that amount you have to pay. Okay, so BigQuery ML, so the abbreviation is BQML. So in this lab basically we are using the London bicycle dataset. So basically it is a public dataset. We are not creating this dataset. There are so many dataset like publicly available. So we will use this London bicycle dataset. Okay, so this is the setup your environment. So these are the very basic things. Okay, let's go one by one. Open BigQuery console. Let's see how to open the BigQuery console. Okay, so we need to find where is the BigQuery. Either we can either search here or we will use this navigation menu. So these are database, these are the networking options, and these are the operations option, these are some tools, these are the big data. So in the big data we have the BigQuery. Just click on it. Okay, done. So this part is completed. So it simply say open the BigQuery console. So we have opened it. Right now, so to train any model, first we need the data set, right? So here we are using the London trip duration data set, like the London bicycle data set. So first we will like explore the data set. What all the columns, what all the data, what is the particular label name, is there any relationship between the columns. Okay, let me show you the data first. Let me show you all columns. Select star from. So this is the public data set and this is the data set name. So no need for the group by. Simply run it. Okay, so this has this many number of rows. So we have the rental ID, duration. So basically we need to find the duration. So in our ML model, our label is duration. So we have the other column as well: rental ID, bike ID, end date, end station ID, end station name, start date, start station ID, start station name, and so many other columns. So first we need to find do we really require all these columns? So how we go to know that? What we will do is we will pick each and every column and we will compare this column with this. So if there is any relation in the graph, so we will see, okay, might be this column is necessary. So first is the start station name. So I think the start station name, there is definitely a relationship between the start station name and the duration. So let's see. So we run the query. So by looking at the query, we will not able to see if there is any relationship or not. We have to scroll through all the rows, right? But if we explore the data, explore with the data studio, okay, get started, authorize. Okay, basically 1 minute. Okay, so see, we have to find the trip duration, right? And we know we have this so many columns. So one way is take all the data, just train it, right? So if we took all the data like IDs column and unnecessary other columns, so our model will not be very efficient. So what we need to do, we will need to do some the feature engineering. So in the feature engineering, we will like identify, okay, what all columns are necessary. So it's very difficult, like just by looking at the data, how we know that, okay, whether this column is necessary or not, right? So very easy approach is take each and every column, make a plot with our destination column, and see if we found uh, anything in the graph, like okay, with the with the station name, the duration is getting increases or not, whether the duration is getting decrease, any, you can say any trend. If we found any trend, then we can consider that column as important column for our model. So first we to the start station name, okay, see whether the start station name, see to check whether the duration of a rental varies by station or not. So we don't know as of now whether the duration will be depend upon the station name or not. So we will just run our select query. 1 minute, let me decrease the size. So we will just run our select query, select start station name and the duration name. Just we will find the start station name and the average duration name from the particular our public data set, and we run it and we have explored it. So by default, like automatically this table will come, but this is again the tabular format. We need the some visual format. So we have so many charts available, so we can pick any chart. So in our lab it has been mentioned that we need to pick the column chart. So we have picked the column chart, right? Let me show you. So here it has been mentioned that we need to pick the column chart. Okay, as soon as you pick the column chart, so automatically this figure will come, right? So by looking at this figure we see, okay, does it mean for all the stations the duration is same? No, basically it is the some maybe record count. So we need to do some customizations here. Okay, so here our metric is duration, yeah, and our dimension is start station name. So dimension is start station name and the metric is duration, and we need to sort by the descending order. I think it's already sorted by the descending. Where is the descending? Sort by duration in descending order. I think it's already sorted in the descending order. We can see the vertical graph or we can see the horizontal graph. Do we need to see anything else? Just apply filter and enable sorting. Why am unable to scroll it? Apply filter and enable sorting. Okay, this is descending. Earlier I am not able to see these fields. Okay, so now we can easily visualize. Definitely there is a trend between the duration and the station name, right? So this start station name is like very important for our model. So we will consider this in our final data. Okay, let's Okay, we can do some other styling as well, like but the bar chart is vertical, how many bars we want to know, like 100 bars, whether we need to show the axis or not. Okay, let's see where it is in the style column. Show axis. Right now we have the 10 bar, we can see the 100 bars as well. So now we clearly see the trends. So for these stations generally the trend is same, but for all these stations the trend is like the average duration is 4800 approximately. I'm not sure whether it is second or probably it is in second only. Okay, so by this way you can analyze the other column as well. Okay, let's analyze the other column as well. So the same graph we were able to see, right? So it is clear that the handful of stations are issued with the long duration rentals, but the majority of stations have the duration that lie in the relatively narrow range. Now we have the other column as well. Let me show you. So ID column generally like not required, so we can leave it. Duration is definitely required because we need to find this column only. So ID is not required. Leave the dates column as of now. So again ID is not required, and station name leave it as of now. So okay, so now we have the like the date column. So now we need to see whether this date column is important or not. Because it could be that like if there is a weekend, like whether we have the Saturday or Sunday, so maybe during the Saturday the person who rent the bike, right, whether it's bicycle or any bike, maybe they return it after a very long duration. So definitely the date will be important for us. So but let's see whether it is really important or not. So this is like a function only, like from the start date we can extract the day of the week, and we are like again we need the duration. Run the query, so the output came, but we will like explore our data set. Let me close this. Again by default like this column will come, so but we will see the column chart. By default the record count will show. Again we will see. Okay, let me minimize it. Okay, day of week, no, not the day of week, it's duration. It's duration. Yeah, so we will see week 1 and week 7. It's basically I think Saturday and Sunday, so the duration is much longer, but during the normal other days of the week the duration is almost same. So definitely we have the trend. For hour of the day, okay, 1 minute, by mistake I have closed that. Column chart. Here is the day of the week. Okay, no day of the week. Duration, it's okay. day of the week and duration. Where is the hour? Okay, we have only two columns, not day of week. So from where the hour came? Okay, for day of the week, your visualization should resemble. Yeah, fine. For hour of the day, your visualization should look like the feeling. Okay. Impact the number of bicycles. So we have the other field as well as the bike count. So again we will see whether the bike count column is really required or not. So how we will know? So just compare, see the trend, if there is any trend between the bike count and the duration. Let's see. So we will just selecting the bike count and the duration from our whole data set. Okay, we found some output, but first explore it. Okay, column chart. Duration. Okay, so almost like every almost it's same only, like 1933, 1830, 1690. So it's not a very like almost same. If you see more bins, 1 minute, because we are seeing only 10 bins, you see the 100 bins. Okay, only for starting 2 3 except almost all the same. Or maybe if we see, okay, we have 1000, one more, everything is same only. So we notice that the relationship is noisy with no visible trend. So this indicates that the number of bicycle is not a good feature. So now we got to know that what all columns are actually necessary for us. So basically the start station name is the day of the week, right? It could be the hour as well. So we know these columns. So fetch only these columns. These are basically not required for this lab. I am explaining so that there is no, otherwise we are just copy paste the query, then it is of no use. We should have some basic understanding why we are executing these queries. Okay, fine. So what he is saying that feature column have to be either numeric or categorical. If the feature is numeric but needs to be treated as categorical, we need to cast it as a string. Okay. Let me close this. Okay, so till now we have explored our data set. We did the feature engineering. So in the feature engineering we have like first see the all columns, then we will see the trend between our label and the every feature, then we will find out okay which feature might be like necessary for us, then we fetch, okay, analyze only those feature, and then we will fetch only those features. Now we have to create a model, machine learning model in the BigQuery. But when we like create a model, we have definitely have to save it. So to save it, first we will like create a data set. So similarly click on this three dot, create a data set. What data set ID we need to give? We need to give as a bike model. Bike model. Location we can select as a EU. EU means European Union. Why we are selecting a European? Because we are using the London data set. So London is in the Europe. And anything else? Okay, just create the data set. We will see the data set is getting created. It similarly as okay, let me close this. Okay, let me cancel it. Okay, now we have to create or train the model, right? So we have some BigQuery ML commands. So similarly we have the create table. So similarly we have the create model, create or replace model. If the model already exists, it will replace it, or otherwise the create model. So the model name is model. So we will storing into this dataset bike model, which we recently created, bike model dot model. And we will like give some options. Okay, which model we have to use? This is a regression type of machine learning problem, so we are using the linear regression. And the label, what is our label is the duration, because we need to find the duration. And what is the data? So after the as clause we have to give the data. In the data we will mention select duration. Okay, this is the label. Start station name, because we found like a start station name is necessary. We found the day of the week could be important for the duration, right? So the day of hour. And from which data set? The public data set. Just I think just we need to run it. That's it. Yeah, just run it. Just run it. It might take 2 to 3 minutes because to first it will create a model, then it will train the model, because we have a large number of records. The statement will create a new model named this. Depending on the type of model, this may take several hours to complete, but it will take a few minutes. Let me pause the video. Okay, query completed, and the model is created. It's the model type is linear regression, location is EU, loss type is mean squared loss, okay, yeah, that's it. Now the second thing is we need to evaluate the model. So how good is our model? So we have the inbuilt function ml.evaluate. So this is the BigQuery. Let me close the model. So BigQuery ML is basically, as I told you in the starting of this lab, like BigQuery ML is, we will use the BigQuery service in the Google Cloud, and to run simple SQL commands to deal with the machine learnings. Okay, so we found here the mean absolute error is 1025, the mean squared error is this, the mean log error this, mean absolute error this. So what all like all this. So okay, so the mean absolute error is 1026 seconds. So if we convert 1026 seconds, it could be around 17 minutes. So 17 minutes is like for the testing data set. If someone give me station name, whether it is a weekend or which day of the week and the hour, and let us suppose we found that okay, maybe it will take 1 hour 17 minutes. but actually might be it will take 1 hour, or might be it will take 1 hour 34 minutes. So we have the loss of the 17 minutes. So the average error could be around of 17 minutes. So can we improve this? Can we decrease this mean absolute error from 1026 second, or from 17 minutes to a little bit less, might be like 10 minutes or 15 minutes, so that if we predict, so we can predict it very closely, not with a very large number of gaps. So let's see what we can do, how we can improve the model. So the one way of improving the model is, right now if we see the data, in the data we have like 1 minute, let me open the notepad. Right now we have the days of the week, right? So in the day of the week we have the 1 2 3 4 5 6 7, right? And we know for the days of the week, like let's suppose 1 is the Sunday, and 7 is the Saturday, or right, and all these are the like Monday, Tuesday, etc., right? So can't we convert, rather than all these 7 categories, we can create only 2 categories, like just 2 categories, weekday and weekend. So we can give a try and see whether we can improve our model or not. So copy it. So what basically we are doing is, we are like recreating our model. Basically now it will replace the model, everything is same, but here we are like whatever the values between 2 and 6, we are as the weekday, otherwise the weekend. So we are basically categorize our one of the columns, and we'll see whether we can decrease the absolute mean error or not. So this is the command to find the evaluation. Okay, it is running. Actually it is retraining it on the same data, so might be again it will take 2 to 3 minutes. So the purpose of this lab is basically we need to know what is Bqml. Like if someone asks what is Bqml, can we like prepare the machine learning model using the BigQuery? Yes, we can prepare. So what all the functions we will use? Okay, we have the inbuilt function like ml.evaluate, ml.predict that we will cover in later slides. So we need to first create the data set, we need to create the model. So what is the command to create the model? It is create or the replace model, right? Can we have to use all the like columns? No. If we use all the columns, then definitely the evaluation, the like we'll face very large error. So first we see the trend using our BigQuery, using the data studio, and we will analyze. Okay, we will do the feature engineering. Basically we will analyze what all columns are necessary, then we will use only those columns. Then we will see, okay, we will get the error of 17 minutes, so which is very large. So can we reduce it? Okay, let's try by reducing it by using the by categorizing into weekend and weekdays. Is it completed? Yeah, it's completed. So we will create a new model by model underscore weekday. So model underscore weekday, and let's run it. So now you will see the mean absolute, earlier it's 1026, now it decreases to 966. So maybe like earlier it is of 17 minutes, now it get reduced. So our model we have improved our model. So can we improve it further? Let's see. So basically we are doing the bucketize hour of the day. Okay, let's recreate one more model. The hour of the day, we are like creating the 3 buckets like 5, 10, 17. So we can experiment with bucketizing with 4 variable into like for minus infinity to 5, 5 to 10, 10 to 17 and 17 to infinity. That is the hour of the day. Like when the basically the person came, like whether the person came like before 5 a.m. or between 5 to 10 or 10 to 17 or 17 to infinity. Run. So this model will be stored by the name model bucketized. It is again in retraining. It will take a few minutes. Let me pause the video. Query got completed. So one model got created. That is the model bucketized. So let's evaluate it using ml.evaluate command. Okay, now it's reduced further, now 904. So basically, so when we use the original columns like start, station name, hour of the day and the weeks, like week are in the form of 1 2 3 4 5 6 7, we will see the mean absolute error is 1026 seconds. So then we try to improve our model by categorizing 1 2 3 4 5 6 7 into weekday or weekend. Then we further categorize the hour of the day into four bucket. So we have further reduced it. So we have improved the model. It's completed. Now we have to like predict it. So here the prediction is basically on our test data set, right? So on the test data set we again need to perform all these transformations, right? So like we need to convert 1 2 3 4 5 6 7 into weekday or weekend. We need to convert the hour of the day into some bucket like 0 to 5 range bucket, then 5 to 10 range bucket, then 10 to 17 range bucket, right? So do we need to actually perform all these things on our testing data? So answer is yes, but we can like there is a one method, we have the transform method. So if we create our model again and this time if we mention this keyword as a transform, so what it will basically do is it will like store all these transformations in the model itself. So whenever we will use this model on our testing data, it will automatically apply the transformation. So let's run it. Let's read it. What is our best model contains several data transformation. Would not it be nice if BigQuery could remember the set of transformation we did at the time of training and automatically apply them at the time of prediction? It can using the transform clause. It will again take 2 to 3 minutes. Let me pause the video. Okay, so query got completed. Let's predict the model. So just using the ml.predict method. So we predicted the duration. We give the station name, we give the start date. So the from the date column only we extracted the like the week of the day and the hour of the day, and now we predict the duration. So we predicted is 2390 seconds. So in above query we just predicted only for one record. Now we can predict for the multiple records as well. See, now for all these things we have predicted the duration. Now we have to examine the model weights. So again we have the like inbuilt command ml.weight, ml.weights. So basically in this we need to know all these things now, like do we have the command like create model, ml.evaluate, ml.predict, ml.weights. So we have like found the weights. Yeah, that's it. This is the end of the lab.